They were in San Francisco. That's why I say that.
But
So.
it
I never
is-
would have guessed.
It is the best. That was the best
Well,
in a
well,
previous hackathon.
Yeah, you guys actually won. They won the Project Tango. So
But
this
they're,
is
the Project Tango
so this is
challenge.
an improvement.
the Project Tango challenge. Yes.
Improvement.
It's a 2.0 version.
Yeah. So the pressure's on. I better not stop.
All right, awesome.
Thanks.
Yeah. No worries, man. No worries. No worries.
So you guys have to be really good.
Hopefully. I guess Damien, can you take care of the change in the slides for us? Or does this work? No.
You guys have spell check installed on this?
Well, it depends which way you spell whiskey. There's the Irish way and the Scottish way. It's actually a joke I had with my buddies at the last hackathon.
Keyboard?
Okay. Yeah. All right. So we're Team Whiskey Tango. I'm Mike Ross.
William Jacobs.
Jordan. Mohammed. And so at the last hackathon, we were able to play with the Whiskey Tango. A buddy and colleague of mine out of our Tampa office bought one right before the hackathon so we could play with it, try and figure out a little bit about it. What he was able to kind of figure out is it's not quite yet ready to replace the Pharaoh's laser scanner, but the mobility and the low cost can really hopefully benefit us. So we're trying to figure out a better way to use it, a more user-friendly way to use it, so someone can actually, without any real training, go out there, scan space, and we can trust it. We don't have to worry about moving things around or anything like that. So we explored 4 different areas. Geolocation, it has no idea where it is in space. Improved the workflow of it. It's a little finicky, so hopefully some better operations, some really good kind of best practices there. And combining different scans, so if we come back and want to redo a scan, we can actually use it and know where we're at. We also looked at some other options for enhancing it, which was something that could read equipment labels.
So as far as geolocation is concerned, a lot of our problems on a construction site is you don't know where you are, or as a facility manager, maybe your first time in the building, you're a little lost. So if you can walk around with the Tango device and kind of know where you're at, and it tells you where you're at, so you're not guessing or looking at drawings, figuring that out, that's helpful. So one of the issues we ran into with the Project Tango as it is right now is it doesn't know where you're at. So as soon as you start a scan, it starts from north is the way you're facing, and the origin is where you're standing. So every time you stop and start scanning, you have to reset the origin, and then if you want to register it later, you have to kind of go in and mix and match. So there needs to be some work there. And then we looked into an alternate solution. I mean, you can see that in the picture on there with the model, and then the scans kind of all coming in way off to the side. So the solution that we looked around, a workaround that would be a Wi-Fi heat map, to try and figure out where you are in the building based on the strength of Wi-Fi signals. And other people have worked on that, so we just kind of tried to see what we could do with that, to see if that can figure out if you're in a certain room or not in a certain room and where you're at, and then map those together. That would take a good amount of effort to figure out a little bit better, but that's kind of the start of where it is. So another current issue with the Project Tango scanning, as far as usability, is it comes in as an SRV native file format, which is fine on the device, but ultimately we need to use it in Navisworks or A360 or something like that. So we have to export it in the Tango to an OBJ file, and then we have to export it again to an FBX file, either in Blender or Unity, one of these other softwares. And then we can get it into Navisworks to actually use it and compare it to all our CAD or Revit or other models. So we need an improved workflow to get there, and that was one of the goals, was to make an app. We didn't quite get to the app, but we did get to the idea of what it should be, which is something directly to Unity and then Navisworks. So that would save a significant amount of time with the scans.
Alright, so operation, like I was saying before, it's kind of finicky. Biggest thing is it gets lost very easily. If you look up at a light, it's sending out an IR signal to that light, so when it comes back to figure out where it is, the IR signal gets lost within the light, so it can kind of shift where it thinks it is. Any kind of solution we can come with kind of helping the mobility aspect, because at the same time you're going to be walking, moving all different directions. it kind of almost seemed like we needed a robot to actually move it in very slow incremental sections so that it wouldn't get lost and screw up your model ultimately. And basically some operational solutions we come up with to fix it was really just, like I said, going slowly, kind of avoid a light. You almost have to kind of scan around the light and not look directly at it. Reflective surfaces also have the same issue, as well as any just dark black screens like a TV, one downstairs, caused me all sorts of issues when I was trying to just scan the wall. So here's an example of downstairs. I was trying to go around a column, and you can see there are a couple examples of it getting lost. So the bench downstairs, you can see where the 3 arrows are pointing. That's the same edge of the same column, or bench. So it's kind of losing its position, getting off anywhere from an inch to a foot. There was one model that I basically just went around the column 3 or 4 times, and it ended up growing about 4 inches in size. Another issue was the elevation changes. Usually it's when you're getting a reflection back from the light, it would kind of lose where you actually are in the z-axis. So you can see there's a reflective surface on the magazine downstairs where it actually thought the bench was lower than it actually was because of the reflection it was getting back. And then something that always just bothers me is when any kind of floaters in a model where they're just off in the middle of space because an architect was working on something and didn't take it out when they were doing it. So we have multiple little folded floaters where it got a reflection back, thought it was something, but it was actually just a groove bounce. So this was the test of combining multiple scans. So I did a whole bunch of different scans and kind of pieced them together. As you saw in that kind of first slide, they all ended up in the same origin point. The issue with trying to do one giant scan of an area is as you kind of go along with the space, you're kind of slowly losing where you actually are in the full round of things. So by breaking it down into kind of smaller sections, you're able to get slightly improved accuracy. In the end, it's only really as good as you line it up in Navisource or whatever other program you're using. So we're still only really that kind of visual representation space, not anything for an actual model scan like a 3D laser. And here's just another view of the same hallway downstairs where you can see the model doesn't quite have all the stuff up above, because if you look in the bottom right, that has a couple more cable tray and wires and stuff. And that's just showing kind of the overlay of the model in space. Another issue I didn't really touch on yet was the way the Tango application puts color into the application itself in the bottom left. It loses all that when you export it because it has kind of its own programming for the color. So it gives you an X, Y, and J at each point, or X, Y, and Z, and then it has this random I and J, which we weren't able to figure out how that color coding would fit in when we exported that.
So as far as enhancing the Tango and other field tools for that equipment label reader would be something incredibly helpful. So right now, if we have to collect data on model number, serial number, unit number, a lot of basic construction data that we're collecting throughout the process, we have to take a picture, write it down, or punch it in your computer tablet as you go. But either way, you have to take the picture and then do a separate process of logging the data. So our goal was to have that picture taken just like a business card reader, kind of scan that, and it reads the data for you and plugs it into the field that you're interested in. Because that would save a significant amount of time. It's a little more complicated than a business card scanner just because every model number or every unit by different manufacturers is going to be different, and you're going to have different data for everything. So you probably just need a much bigger library. We didn't complete a library of manufacturer stickers or anything, but we did get to a point where we kind of isolated certain boxes of data, and you can get to that point and export it.
So kind of wrapping up, it's really more what we learned. So our ultimate goal is to have a real-world application that anyone can use, and the Tango fits in my back pocket. So I can easily give this to a superintendent out in the field. He can do a quick scan, hopefully with no training. That was our end result. We didn't quite get there. As we dove into Unity, we found that we could easily create a new app to put it into the Tango using Unity. But anytime we changed something, it kind of changed something else that we weren't expecting. So we kind of kept going back to square one as we tried to kind of manipulate it. So the next step really is kind of learning more about what that AEC programming is so we can actually do it. The ultimate value of the Tango itself, we're really going to hopefully hopefully find that out tomorrow. My VP expects me to do something with it tomorrow. We're supposed to be scanning basically a baggage room at an airport, so that us and the architect, as we're doing our survey, can use that to hopefully go back and kind of finish up the budget as soon as we find it. So hopefully everything I've learned today and over this weekend will be able to kind of be applied tomorrow. But we weren't able to really get that app where we wanted it. Honestly, the technology is close. We are right there. There's just like a couple little issues that we need to solve to really get it there. But we're hoping to get something with, since Michael specifically has two of these, we really kind of want to be able to use what we have and not have it be a waste. So we're just kind of leveling up to Google and we'll keep going with that. So I have a couple of challenges. There's no kind of monetary prize, but for future challenges, we'd like to actually develop the new constructor app for the Tango, so that it's a little more usable by pretty much anyone and not kind of specific to people who are tech savvy. And the power flow, my colleagues and I just keep pushing this and trying to build it, make it easier. We did come up with something last time, but it wasn't quite easily deployable. So we're hoping to kind of simplify it where you literally are putting in just one little bit of information about where the power is being fed from, and it does a quick graphic display. That would hopefully be mobile based, so that you don't even need an app. You just punch in the website and then put in what piece of code you're at. Those are some of the resources, and just a last thank you for Penn State, CBI for letting us use the space and everyone to help bring together. All questions?
Well, first of all, a round of applause for sure. Any questions from the judges?
You mentioned the technology you thought was there. I just wanted kind of a clarification, and just basically ran out of time. Or do you think that for instance, you're scanning on the column and so forth, some of the challenges that you had, for lack of a better term, needing to stitch it together after the fact, and some anomalies so is that the technology, or is that just learning how to utilize what is existing?
I guess it's kind of a combination. If we can make the software be able to use something else like Wi-Fi geolocation or something else to kind of help locate it, then I think the hardware is fine as it is. If on the flip side, if we can get the hardware to be able to kind of pull something else in, or some other maybe little point being sent out to help it locate itself, then that would solve the issue too. So in saying it's almost there, it's yes, we can use it, but not necessarily to the accuracy that at least I would like to see.
And did you see a big difference in that usability in the Z-axis versus the X and Y?
I'd say the Z was usually pretty good. And even like changing elevation, like I went up the stairs and came back down, and I was usually pretty much there. It was really usually the reflective surfaces, or the biggest problem is if I turned too quick, it would immediately get completely off. Like I was even trying to follow like the joints in the concrete, and if I turned and came back to that same joint, I could be anywhere from an inch to like 6 to 8 to a foot.
The relative change.
Right. So the biggest thing I would say is turning, which again, like trying to keep its costs down. It's a mobile, easy device, but it really seems like a little robot that has a specific speed it goes at is
Sure.
almost the best option, at least the way the program and software all that is.
Great. Thank you.
I saw 3 applications that you could have written. I get there was the Wi-Fi heat map, improved spatial locator, and then there was the reading of the equipment labels using the business card reader app as a big, and then the improved workflow in Unity. Did you actually write those applications? Are they working applications today that can be used on Monday?
I would say we got maybe 3/4 of the way, halfway through the business card reading part, but the other one's not.
Yeah, the other one we just had problem after problem after problem. Yeah, like I was saying before, it's more, I think we need to learn more about what the base programming is, which Google has a wealth of knowledge on the website. It was just, it's a mixture of kind of learning Unity as well as learning all that background code they had in there.
Okay.
Questions, Mikako?
I think we already told the detail what you did last time.
Yeah, if you just want to quickly say
what was the goal of Whiskey Tango last time, and then just elevator pitch on the iPower?
So the goal last time was really kind of figured out because we'd only just gotten it for the Tango, that is, and we were also trying to do kind of a comparison since we had Pharaoh's 3D laser scanner there on a general comparison on how accurate it is. Can the Tango actually replace it? And it's like less than a 10/100th of the cost. Like, ridiculous. And then the power flow is just something we've just been kind of constantly working on in the background. My colleagues and I that keep coming to these. It's started just kind of trying to pull one-line diagrams out of Revit easier, and then it kind of turned into all the other applications we could do with that information. So it turned into more of being able to look at a one-line diagram anywhere, or just one piece of equipment, see what's feeding it, what it's feeding, as well as any other information we want to add in, like commissioning information, submittals, etc. We know there's a couple applications that do that, but they're kind of expensive and not necessarily easy to use. It's not something I can just give to my superintendent and say, hey, type in this information into an Excel spreadsheet, upload it here, and now you can use this for the rest of the project.
Okay, good. Yeah, this will be a demo. This will be an example that I have to keep participating in this competition. Thank you.
Awesome. Any other questions from the judges? Man, you guys are quite into user experience people for Google and their Project Tango, so a round of applause.